right. Good morning, everyone. Welcome to today's class. Today we will talk about data management. We will use about 3 lectures to talk about this topic. There are 4 small sessions. Hopefully today we can finish the first 2 sessions. They are data wrangling. So what is data wrangling? Basically, it's the process of transforming your raw data to a clean and organized data set that is ready for future usage. For example, for machine learning modeling or for visualization, etc. And in this small session, we will cover all of the following topics: data exploration, how to manage one data frame, and how to combine 2 data frames or more data frames, and then grouping and looping. So in the first topic, we will talk about how to create a data frame by ourselves and how to describe a data frame to understand the features of a data frame, for example, the shape, and then navigating data frames. So this is the first topic. And then in the second topic, we will talk about a lot of details about handling one data frame. For example, how to subset the data frame, selecting rows based on position or some conditions, and how to manage columns. For example, how to select columns, how to drop columns, how to rename columns, etc. And in general, how to replace values in a data frame. Sometimes there are some values that are not correct, or you want to change the type of data, for example. And next one is how to handle missing values. So in this particular small session, we will only talk about one way to handle missing values. And in the last 2 sessions, we will talk more details about it. Okay. And then calculating summary statistics, finding unique values, etc. Okay. A lot of small topics in this part. And the third topic is grouping and looping. So we'll talk about how to group rows by some variables and how to apply a function over all elements in a column or in the entire data frame. Basically, we'll talk about how to use the apply function to manage your data in a more efficient way. Okay, and so the last topic is more than one data frame, how to concatenate and merge data sets, data frames. All right. So the most common data structure in machine learning is data frames. Data frames are tabular, 2-dimensional data. Rows are corresponding to subjects or individuals or observations, or in machine learning, in the computer science world, they call them samples. Each row is called a sample. Okay. In statistics, we say a collection of observations is called a sample. Okay. So just two definitions of the same thing. Okay. And then, so let's take a look at a data frame, which is about passengers on the Titanic. So this is a public data frame. So let's load the data frame. First import pandas as PD, and then we will import the data from an online resource using pd.read_csv. This function is used to load CSV files, right? Okay. And then we show the first 5 rows. So it looks like this. A few variables: name of the passengers and passenger class, age, sex, survival status, whether or not the passenger survived or not. And then sex code. So apparently sex code and sex are explaining the same thing, describing the same thing, but they are coded in different formats. Sex is a categorical variable, and sex code is a numeric variable with two values, 1 and 0. So this is a data set. This is an example of a data frame, two-dimensional. Each row is corresponding to one observation. Each column is corresponding to a variable, and the content is the value of the data. All right. So this is pretty much what I just said. Okay. And then let's first take a look at how to create a data frame by ourselves. So Pandas has many methods to create a data frame. In particular, we can do the following. So first, we can create an empty data frame. Just use the data frame function parentheses, then it's empty. We call it data frame 2. And then we can define each column one by one by ourselves. So for example, we first define a column called name, and then enter the values in this column. Suppose we only want to create a very small data frame with 2 rows, 2 observations, so 2 names. And then the corresponding ages of the 2 individuals. Right? And then whether or not the person is the driver in the car, for example. So it's a logical vector. So notice that in each assignment segment, we specify a list of values for each column. And then let's run this. So data frame 2 is a mini data frame, 2 rows, 3 columns. So this is a simple way to create a toy data frame by ourselves. Right? So sometimes you just want to test a very simple model, or you just want to have full control of your data frame, then you can create it by yourself. So in the real world, we rarely need to create our own data frames. Usually we just import raw data from different sources. For example, last time we talked about how to import data from online resources and also from local folders, right? And we can import different formats of data, CSV, Excel, JSON. And after we import our data set, we need to understand the data, right? Let me see, I have a question. Can you also data wrangle with SQL? Yes, of course. But there are some Python packages that are very similar to SQL. The syntax are very similar to SQL. Actually, Pandas, the Pandas package, you will tell if you know SQL already, you will tell that many functions are very similar to SQL functions, SQL commands, because Pandas is trying to imitate the operations in SQL. Consequently, Pandas is very efficient too in dealing with data frames. But we will not talk about SQL in our class because we have packages that are very similar to SQL. Okay? But definitely you can use SQL to manage data frames. Okay? All right, now let's see how to describe a data frame. First, you can show or view the first few rows. So we have seen this. The head function can be used to show the first few rows. By default, it will show the first 5 rows. And for example, the first 2 rows of Titanic looks like this. We can also show the dimension. Dimension is the shape, number of rows and number of columns. So the Titanic data set has these many rows and 6 columns. It's a very small data frame actually. And you can also calculate some descriptive statistics for a data frame. So in pandas, there is a function called describe. Right? So pandas data frames have this method, associated method called describe. And by default, it will only focus on numeric variables. So it will automatically ignore categorical variables. Categorical variables are variables with values that are character strings. So for example, if we call the describe method and apply on data frame 3, which is the Titanic dataset, you will see this, you will get this table. Okay. So for each numeric variable, the function will calculate the number of valid observations, non-missing values. So for age, there are 756 of them, survival, and sex code. So these two variables don't have missing values, but age has missing values, a lot of missing values apparently, right? And it also calculates the mean and standard deviation for each numeric variable, and also the 5-number summary of them. So it's a very good way to summarize your numeric variables very quickly. Have a very quick look, and you can also see how many missing values there are. You cannot tell, actually, you cannot tell. Yeah, so this is just the number of non-missing values. You have to combine the information that you got from shape, okay, the shape function, to check if there are any missing values. And so this is a summary of what we have seen, the head function. And the tail function is similar to the head function, but it will show the last 5 rows by default. And just pay attention when you look at the summary statistics that you get from any functions, pay attention that some categorical variables are coded as numeric variables, like binary numeric variables. For example, sex code. Sex code is numeric. It has only 2 values, 0 and 1. But pandas functions don't know that it is actually a categorical variable, so it treats it as a numeric variable. That's why it calculates the mean, standard deviation, and the 5-number summaries for it, although they don't make much sense for this variable. So in this case, it's better to either recode it, encode it into a real categorical variable or a factor variable, or you can use some other method to summarize this column. All right. The describe function actually can be used to summarize categorical variables too, if you specify include equals all, quote all. So that means you want to describe all of the variables, including categorical variables. Okay. So for example, name, passenger class, and sex. So these 3 are categorical variables. So for categorical variables, the information that is provided by the describe function is very limited. You can see that it only provides a number of non-missing values and the unique values for the variable and the top category. Top category means the category that has the most observations, most number of observations, basically the mode of the categorical variable, the most frequent category. So apparently for name, the name variable, there are 2 rows corresponding to this person. In this case, Connolly, there are 2 observations. Similarly, for passenger class, there are 4 unique values. And the top category is the 3rd class, which means this class has the most number of observations, the biggest frequency, which is 711. Okay. And for the mean and standard deviation and the sum number summaries, so it returns missing because, of course, we cannot calculate these for labels, right, for categorical variables with label values, etc. So you can force the describe function to describe your categorical variables. However, the information provided is very limited. And a better way is to use some other functions. And another function to have a big picture of your data frame is the info function. Let's run this. So the info function will tell you the class of the object. So our data frame 3 is a pandas data frame. And number of entries, which is number of rows, and the row indexes, and number of columns. And then for each column, it shows you the number of non-missing values and and the data type of the column. Right? Object is kind of anything, basically is categorical. Right? Is categorical. And float, a real number. And integer is, integer, numeric integer. So you can have a very good idea about the entire data frame, right? Especially the number of non-missing values. So this is very important. For example, in this case, age has a lot of missing values. You can choose to delete observations with missing values in age. However, by doing so, we will lose a lot of data points. Right? We might not want to do it. In this case, we probably want to figure out a way to impute missing values in this column. If there are only a few missing values, for example, 1, 2, 3 missing values, then we don't bother to do it. We can delete it because we have not very small sample. We have 1,313 observations. It's not too small, so we can delete a few observations. We can afford that loss, but we cannot delete like hundreds of observations because we only have about 1,000. All right, so the info information is very useful. Now let's move on to subsetting data frames. Okay. So first, let's focus on rows. Okay. Selecting rows. We can select rows via location, just like what we did for matrices. Okay. There are two functions, the LOC function and ILOC function, location and index location. So the index location function can be used by selecting rows using the indexes, row indexes. For example, if we want to select the first row of the Titanic dataset, we can say this. We can use the square bracket 0. Okay, so this is the first observation. We can also select multiple observations at the same time. For example, the second, third, and fourth. And we can, if we know that we will start from the first observation, then we can omit the starting index, which is 0. Okay. So from 0. So iLoc function is very similar to some functions in R, okay, some other packages. And data frames do not need to be numerically indexed. You actually can use other variables as an index variable. So for the Titanic data set, the name column is almost kind of, you can use it to identify rows. It's almost 100% correct. Of course, in the previous slides, we know that there are some repeated values in name, not a lot, maybe 2 names have repeated values. But still, it's a good option for index. So we can use the set index function to specify a new index variable. For example, we can maybe name, And after we run this, then the index is changed to the name column. And then you can use specific name to extract information about that row. Okay? So if you want to use the location function, LOC, you should refer to an index variable which is categorical with label values. So it works too. We rarely need to do it because usually there should be a row index already built in the data frame, so we don't have to specify an index. All right. So in summary, there are two functions that we can use to select rows according to their indexes. And most likely, we will select rows based on some conditions instead of just relying on positions. We probably want to use some conditions to select rows. For example, if you want to select observations that are female, we can do this. Just use the square brackets and put this condition in the square brackets. Data frame 3, the sex column is equal to female, quote female. Pay attention, you need to be very precise when you state the condition. Everything should be absolutely correct. Right? The variable name should be quoted, right? And S is capitalized, sex is capitalized, and female are lowercase, quoted. Right? If there is any error in this condition, then it won't work. And also pay attention, the sex column is not recognized, cannot be recognized by Python directly. You have to refer it, you have to say it's the sex column in the data frame 3 data frame. So this, and also I saved the result in a new data frame called df3f. This is the shape. So that is because for all pandas data frames, whenever you do any operation on the data frame, the result will not be saved. It will not affect the original data frame, but instead it will create a new data frame. You have the option to save it or just print it. It's okay. If you, for example, you don't want to save it, you can get rid of this part. It will still work. You can see the output, the result of this operation. However, data frame 3 will not be affected. If you type data frame 3, the shape, everything will be the same, as the original version. It will create a new data frame, but if you don't want to save it, it will be lost after this, you run the cell, okay? So this is the default behavior for pandas data frames because it tries to protect the original data frame. Just keep that in mind. And we can also check the first 2 rows of this new data frame. Okay. All right. You can also specify multiple conditions, use multiple conditions. You just need to use this AND operator to connect them, combine them together. Okay. I believe you don't have to use parentheses to wrap the conditions, but I recommend you to use them because it will be very clear for you and for your readers, and it will avoid any confusions. Okay? So it's possible to use 2 conditions. So sex equals female and age is greater than 65. Only one observation satisfies this condition. So only one row is returned. All right, so that is select rows. sometimes you want to delete some rows. But actually, the operation is similar to those we used when we select rows. Just use some negating operations. For example, we want to select rows corresponding to male observations, then we can just delete those female observations. This is the same thing. Let's check the first two rows. Indeed, they are all males. And sometimes there are duplicate observations in a data frame. And definitely we want to avoid having duplications because it will mess up our model in the future. So if you want to delete duplicate observations, you can just take the data frame and call this drop duplicates method. So pandas data frames have this associated method. And let's run this and check the shape of the new data frame immediately. Turns out that the new data frame has the same shape with the original data frame, which means there is no duplicate rows. Although we know that there are some duplicated names, right? So maybe the entries of other variables are slightly different, coded slightly differently, so that they are not treated as duplicates. See, the original data frame have the same shape. So from this example, you see that the drop duplicates function will only drop rows that match perfectly across all columns. Okay. So namely, it will only drop rows if it perfectly match some other rows. Okay. In all of the values, all the same, then it is treated as a duplicate row and will be dropped. Otherwise, it won't. Okay, it will just keep out everything. Right. And the related method is duplicated. Okay. So this one will return a Boolean series denoting if a row is duplicate or not. So namely, it will create a new column. Right? So it will create a flag variable. Right? So if it is duplicate, probably it will true, and otherwise false, etc. Boolean operator. And then let's focus on columns. Definitely you can select a few columns from a data frame. For example, I want to select these 4 columns. Notice that if you select multiple columns at the same time, you need to wrap them in a list. You cannot just do this. Then Python will give you some error. It cannot recognize it because you are inputting one argument, which is a list of column names. So a list of columns that you want to select. Right? So this is one object. It's kind of like column indexes. Right? And you run it. So this is a new data frame. Again, if you want to save the result, you have to name it, give a name. And you can also take a look at the first 2 rows. Deleting columns, there is a function called drop. So this one can be used to drop columns. I specify the column name and the axis. So in pandas, axis equals 1 is corresponding to columns and 0 is corresponding to rows. So it's the opposite with the definition in NumPy. Okay, remember we talked about that before. Okay. But anyway, if you want to drop columns, specify axis equals 1. Then save the result in df3 v3. You see it has 5 columns now because 1 is dropped. So 8 is gone. So that is how to delete columns. You can also choose to delete multiple columns at the same time. Just remember you need to wrap the column names in a list like this. And if a column does not have a name, which is very rare for pandas data frames, but sometimes it might happen, right? Then you can drop it by its column index. So take the data frame and use the columns method to pull out the column indexes and specify the position. Right? 1 means the second column. Okay. And then df3 v5 will only have like 5 columns still, okay? And the second column is dropped. And sometimes you're not satisfied with column names. For example, in the Titanic dataset, data frame, P class stands for passenger class, but P class is not very intuitive. People may not understand what it's about. You can create a new name for it. So you can just call the rename function and then use the columns argument and then specify a dictionary for it. And the order is old name, colon, new name. So the new will be used to replace the old one in this order. So let's save the result in version 6 and then see the first 2 rows. You see now it's called passenger class. Sometimes it's quite useful because sometimes the column names are not named very appropriately. Maybe they are very long or not very meaningful, or there are some characters that you don't like. You want to change them and rename. You can also rename multiple columns at the same time. Anyway, you just need to use a dictionary to wrap those pairs, right? Kind of like key value pairs. The key is the old name and the value is the new name, right? So just make sure that you pair them. See, old, new, and then use comma to separate them, and then old colon new. So by doing so, you can change the names of 2 columns at the same time. This is the version 7 of the data frame. Passenger name and sex been changed. So we're done with renaming columns. Then how about the cells, the entries in a data frame? Sometimes you want to replace some values in a data frame. For example, if you don't like the term like female, you want to use woman to replace it. You can do it using the replace function. So this one is used to replace values. Not column names anymore, it's used to replace values in a data frame. Sometimes you want to focus on a column. For example, I want to change female to woman in the sex column. So clearly specify the column you want to replace values and also the values. Right? Still in this order, old, comma, new. Okay. And then let's run this. Let's see. So this is version 8 of the data frame. Okay, so this is the first 2 of, sorry. So since I only use the sex column, the sex column. So the result only has one column, okay, which is sex. Okay. So now the values are replaced. Female is replaced by woman. So these are the first two observations. 0 and 1 are the row indexes. Okay, don't be confused. This is just a very small data set with only one column, the sex column. And you can also replace multiple values at the same time. You just need to specify a list of old values and a list of new values, and make sure the old values and new values are matched. So they are all matched. List them in the correct order so that they are 1 to 1 corresponding. Okay, so after we do this, let's see that so both female and male are replaced by woman and man. All right, so this is the replace function. And sometimes you want to replace the entire data frame object by specifying the whole data frame instead of the single one. For example, in the Titanic data set, we know that there is a sex code. Sex code is binary numerical variable with two values, 1 and 0. Okay. And actually, it should be a binary categorical variable, right? And also there is a variable called survived, and it is also coded as a numerical variable with 1 and 0, two binary values, numeric values. And if you want to convert it to a sort of a factor variable with character string values, you can replace them too. Right? So in general, in the Titanic data frame, we want to replace the number 1 by the string 1 and 0 by the string 0. Right? So we know that it will be good. Right? So we can replace them at the same time. So in this case, we'll just take the entire data frame and replace 1 0 by 1 0. So then we save the result in version 10. And version 10 has the same shape with original data frame. So 6 columns and 1 3 1 3 rows. But now you see survived and sex code have good text string values. A side note about this is that so it is good for visualization and some calculating summary statistics because survived and sex code are in the correct format. However, it is not good for machine learning modeling in Python because most of the models in Python only take numeric values. Okay, so you'd better create a new data frame and save the result like this and keep the original yes. Right? Still use 1 and 0s for survives and sex code because machine learning models in Python like numeric values. So they basically, most of them don't accept character string values at all. Okay? They don't know how to process them. Okay? Only accept numbers. All right, next one is finding unique values. Of course, it makes more sense for categorical variables because usually they only have a few unique values. For numerical variables, it's not that necessary because that is not what we really care about, right? So for sex, you see there are 2 unique values in the data set. Okay. The reason that we want to pull out unique values is because sometimes missing values are coded in a very weird way, very abnormal way. I use some special character. Sometimes you will see people use 999 to denote missing values, or -1 to denote missing values, etc. Okay, so this function can help us to identify those weirdly coded missing values, okay, or some special categories. And another way to find unique values and also summarize their frequencies is the value counts function. So pay attention, there is an S here. This is a very useful function because for categorical variables, it will create a frequency table for you, and basically a distribution table. You'll see male this many and female this many. Okay. A very convenient way to summarize a categorical variable. And if you want to calculate category proportions, you can add this argument, normalize equals true. Let's see, then proportions will be calculated for you, and sum is 1. Okay, so this is also very helpful for us to understand individual columns, categorical columns. Right? And pandas also have this function, n-unique. So this one is used to calculate the number of unique values. So for passenger class, there are 4 unique values. So in the Titanic dataset, P class is indicating the class of passengers ticket. Okay? There are actually only 3 classes on the Titanic. However, there are 4 unique values. So let's use the value counts function to figure it out. It turns out that for one observation, the passenger class was coded as asterisk. Okay? So very likely that this is used to represent missing value. So that's why the value counts function, the unique function are very useful for us to understand categorical variables. In particular, you can recognize some special extra categories that you don't expect to see, and you need to figure out a way to handle them. Okay? If you only have one observation in this case, you can choose to drop this observation or use some simple imputation method to impute this missing value. Okay? It will not affect the result that much because we only have one observation. But if we have a lot of observations like this, okay, for example, 500, then you should figure out a way to impute the value. Okay? And then handling missing values. So it is a very common problem in data wrangling. It's not always true that a data frame is clean. Usually they have a lot of missing values. There are 2 functions that can help us to filter out missing values directly. So of course, this is the easiest way, the most straightforward way. However, it might not be the best way, of course. Okay, just pay attention to that. We just start from the easiest and it may be the worst way. So let's see. There are 2 functions, is null and not null. Suppose we want to get rid of all of the observations with missing values in sex. We can do this. Data frame 3 sex dot not null. So this function will return logical values, true or false. So if it is true, then the row will be kept in the result, otherwise not kept. So not null is true means the value is not missing. So it will get rid of all of the observations with missing values in sex. So this is one way. Sometimes you want to examine those observations with missing values in some column. For example, we want to study those observations with missing values in age. We can do this by data frame 3 age and dot is null. So this one will also return logical values, true or false. But it will return true if it's missing. So eventually it will choose rows with missing values in age. So this is the version 13 of the data frame. And then you can do some more calculation, summary job for this data set to better understand those observations. Okay. So let's see, age has missing values. All of them values in this column is a missing value in version 13. All right. And actually, pandas often use missing values. But it is not defined in pandas or in base Python. So in order to specifically call or use a missing value, you need to first import the NumPy package. So import NumPy as np, and then you can call the missing value defined in NumPy, which is np.nan. This is a valid value, which is used to denote a missing value. For example, you can replace all male by missing value. Of course, this is an absurd operation. Just this example just let you know that it's possible to use a missing value as a valid value to replace something or to do something else. So it's, of course, this is an absurd operation. We should never do it. Okay? We should never replace a valid value with a missing value. Makes no sense. Just an example. And then calculating descriptive statistics. So previously we have learned some summary statistics, some functions like describe, right? But pandas has some more functions specifically for mathematical operations or statistics calculations. For example, the max function, mean function, average, and sum and count. Okay, so they are all available in pandas. You can use them if you need. If you don't want to directly call the describe function, you are interested in some specific statistics, you can use them. There are many more. You can just Google the pandas documentation and you see many more functions available for you to use. For example, the variance function, standard deviation function, kurtosis, skewness, SEM. This is kind of useful, standard error of the mean, which is by definition as divided by square root of n, and standard error. And also mode. So this is the most frequent category. Yeah. So all of them are available in pandas. So in Python is very interesting. Different packages have different functions. Sometimes they overlap, but they may have different features. Even if they have the same name, they may have different features. So that's why when we import packages, try to import the package explicitly using the first method. So last time we talked about it. You can apply a function on the entire data frame, then it will apply it to every column of the data frame. Right. So, sorry, any questions so far? Then let's move on. Sorting data frames. So this is also a very useful and common practice in data management. You want to sort the entire data frame according to a variable or a few variables. the function we use is, or the method we use is sort values. There is an S here. Pay attention. There are a few arguments by. So this is a column name or list of column names to sort by. And then axis to sort. 0 for rows and 1 for columns. Usually we sort observations, so it should be 0. We rarely sort columns, okay? It's not very helpful. And ascending, by default, it should be sorted in ascending order according to some variable or a list of variables, but you can change it. If you say ascending equals false, then it will sort in the descending order. And in place, so this is an argument that you can use to change the data frame in place right now. So instead of returning a new sorted data frame, it will just work on the original data frame and change it. So actually this in place argument is available in many methods. Actually, you can choose to do it to change the current data frame. However, I don't recommend you to use it frequently because you'd better keep the data frame intact. Okay. What if we do something wrong, very bad, and then we will ruin the data frame? We don't want to do that. So keep the original data frame intact. It's important. But sort, sometimes we want to sort it. So let's see an example. Suppose we want to sort the Titanic data frame by class. And x is equal 0, that means we sorted along the rows. And in plus equals true, that means we will actually change data frame 3. Let's run it. Now you see, indeed, data frame 3 has been sorted, changed. See, passenger class, according to passenger class, starts with asterisk, and then first class, and then second and third. For numbers, it's just in ascending order. For character strings, it will follow the alphabetic order. All right, so this is the last slide in this small session. We talked about a lot of topics, very small topics, but they are very useful, practical skills. Got it? Question? Does Python utilize the pipe operator similar to R? Yes, there is pipeline. We'll talk about it a little later, but usually it's not used for data wrangling. It is used to build a pipeline for machine learning. Usually it will start with read the data and then pre-process the data and then use some machine learning models to fit the data. Okay, so usually the pipeline is used for machine learning, not for data wrangling. Yeah, I have never done this. You use pipeline. I have never used pipeline to do data wrangling. Maybe it's still possible, but pipeline is a function in Scikit-Learn. I think it's a machine learning function actually. All right. Good question. All right. Any other questions? Great. Let's move on to the second small session in this module, data wrangling 2. So in this small session, we will discuss grouping rows, looping along columns, and handling 2 data frames. So first, group rows by values. So far, when we summarize the data frame, we just treat it as one object and do everything on the entire data frame or the entire column of the data frame. But actually, we can group the data and calculate statistics for particular groups of a categorical verb. So let's load the Titanic data set again. And then suppose we want to compare the average set, the means of all of the columns for each sex group. Right? We can do this. Group data frame 3 by sex, and then we can call the mean function. Now let's see what we get. So then this small table is returned. So apparently the mean function will automatically ignore categorical variables. For example, name and passenger class, it automatically ignores them and only calculate the average or the mean for numerical variables, age, survived, and sex. The point is the data is first grouped by sex so that you can compare the mean age between the two sex groups and the survival probability for the two sex groups. Okay, for example, female passengers had a much higher survival rate compared to the male passengers. And sex code, mean and female and male. 1, 0. I think it's rounded somehow. It's rounded. All right. Now let's move on to next slide. So group by is where data wrangling really starts to take place. It's common to compare some summary statistics among groups. For example, you might want to compare the survival probability among the 3 passenger classes, right? Since so focus on survived, so you see that the first class has the highest survival rate and third has the lowest. So you can kind of write your observation. Based on this observation, you can write a story about it. Okay, try to understand it, why it is true. But unfortunately, for beginners, it's common to write the code like this. I take a data frame, group by something, and you expect to see something, but actually nothing will happen. Right? Just say, okay, you try to group by it, but nothing will be returned. Right? That's because the group by function must be paired with some operation. For example, mean, standard deviation, etc. Okay? Otherwise, you will not do anything. And you can use this function to compare some summary statistics. Okay? For example, how many survived, how many died, using the count function. Or you can study the relationship between 2 categorical variables and the response variable survived. By doing this, group by 2 categorical variables, passenger class and sex. Then within each class, you can study the relationship between male and female group, right, the survival rate. And you can also reverse the order. So first, group by sex, and then passenger class. Then you will see a different dimension. Right? In the female group, which class has the highest survival rate, which class has the lowest. And whether or not the pattern is consistent among the 2 sex groups. So this is another story, okay? Another way to explore your data and create some hypothesis sometimes, right? Based on summary statistics, you can have some hypothesis, and later on you can use machine learning models to verify it. Of course, we can also group the data by two variables and call the age column and describe it. So by doing this, you can compare multiple summary statistics for a numerical variable for different groups of data. So it's also a very good way to study the relationship between categorical variables and numerical variables. This is especially useful if your response variable is a numerical variable, and you want to see which categorical variables has very big influence on the response variable. So a very good way to show it. All right. Now let's move on to looping over a column. You have the option to use a for loop, for example, to print out something in the column. That means you are looping along the column. Looping means starting from the first observation all the way to the last, a fixed loop. So for example, for name in the first two names, 0, 1, I print the uppercase name. Apply the upper function on the name and then print it. Do this. It works. So, however, as I said previously, looping in explicit loops in Python are very slow. So if we can avoid it, we should avoid using a for loop or a while loop. Instead, we should use implicit loops. In Python, we have a method called apply. So this is very similar to the apply family of functions in R. I believe Python imitates the apply functions in R. So it creates this apply function in Python as well. So it will apply the same function on each item or each column or each element in a vector. So let's see how it works. So we first create a function called uppercase. It will take a string and call the upper function to make it uppercase. Okay, so call it uppercase. And then this function is defined. After this, we can apply it on all of the components in this column, the name column. And of course, I only want to extract two of them. So this will essentially do the same thing that we did using the for loop. Okay? However, this one is more efficient. It's supposed to be more efficient. So you might wonder, why don't we just put upper here? That's because this upper is not a function. It's a method. It's a dot method. You cannot directly put a dot method here. It must be a real function. You can define it by yourself. You can also apply a function by a group. So first group the data by sex, for example, and then apply a lambda function, calculate the count. So see, this is an example of using the lambda function to create a short anonymous function. So see, this function is created and used right away without a name even. So let's see how it works. So basically, it will calculate the non-missing value, number of non-missing values for each variable for each sex group. have this nice looking summary. So this is an example of using the lambda function. Basically, the apply function can be used to apply an existing function on anything, a grouped data or a column, etc. And the function can be created right away within the apply function. You call it using the lambda. And yeah, alternatively, you can, if you don't want to use the anonymous function, we can create a new function called CT. It stands for count. And then it takes only one argument, and we apply the count method on the argument. So then we can use it right away by the same result. If you don't want to use a lambda function, you can use a def function to create a real function, a regular function. Then let's move on to handling more than one data frame. So first, concatenating data frames. Concatenating means just combine them together, join them together. Two directions. You can concatenate two data frames vertically. Essentially, you will stack two data frames vertically like this. Okay. So in this case, of course, the two data frames should have similar columns. Otherwise, it doesn't make sense to stack them because then each column will have different variables. Okay. The function is called concat, and x is equal to 0 means concatenate along the row axis. And okay. Let's see one example. We first create two small data frames. The DFA look like this, okay. 3 rows and 3 columns, ID and first name and last name. So very simple data frame. This is called DFA. And then the second data frame called DFB, it also has 3 rows and 3 columns. Okay. ID first and last. And ID have 3 different values for classes. So apparently DFA and DFB have exactly the same columns and column names. So they are kind of like two parts of a data set. Maybe one is old data set, one is new data set, a new data set. Then it makes sense to concatenate them vertically. The syntax is like this. Like the concat function is in pandas, so don't forget to refer to the library. And then use a bracket to wrap the two data frames you want to concat together and specify the axis. And then this is the result. Again, we didn't save the result, so it will be gone after we quit Jupyter. If you want to save the result, name it, give a name, and assign it. So this is how to concatenate two data frames vertically, okay, stack them. And you can also concatenate two data frames horizontally. You just need to specify axis equals 1. That means along the columns. So our DFA and DFB have the same number of rows, 3 rows. So it's actually very convenient to concatenate them together. So Python allows it, no problem. However, you see, the result is not so good because now it is not a tidy data frame anymore because each row is not corresponding to one observation anymore. It contains information from 2 individuals and it's quite messy. It looks neat, but it's quite messy because you cannot analyze them in a good way. So instead of concatenating data frames horizontally blindly, using the concat function. A better practice is to use the merge function. The merge function is similar to the different joins in the R package dplyr. So again, this is also similar to some function or commands in SQL. You will see. Let's take a look. So we first create a data frame called a df employees. It has 4 rows and 2 columns, employee ID and name, very simple. And the second data frame called df sales. So this one contains the information of employees' total sales, so employee ID and total sales. So apparently we have a main data set and a data set which provides some supplementary information. Right? So it makes sense to merge them horizontally. To merge them, we can call the merge method function in pandas. Just list the 2 data frames you want to merge, and then lastly specify the column that you use to do the matching work. So apparently both of df employees and df sales have the same column called employee ID. Naturally, this should be the column. And by default, the merge function will do an inner join. Namely, it will only contain or keep the observations with matching values in the unvariable. So in this case, only 3 and 4 are kept in the result because 5 and 6 are not contained in the employee data frame. And 1 and 2, employee 1 and 2 are not in the sales data frame. So only the observations with matching values in the employee column are kept. So this is the default behavior for the merge function. So there are 4 joins, 4 types of merges or joins in Python. So this is very similar to the join functions in dplyr. So inner join default, outer join. So this is the most generous one, which will keep everything intact. It will not delete any observations, no matter there is a matching key value or not. Left join will keep the left table complete. And right join will keep the right table complete. So these are the definitions. For example, left join is commonly used in practice because it will keep the left table complete. So usually when we do merge jobs, one table, one data frame is considered as the main data frame. And we have some metadata, some additional data frames. We want to add some more information, more columns to the main data frame. So we always want to keep the left one data frame intact, complete. We don't want to lose any information from the main data frame. Then we should use the left join. So the right table in this case will not be kept intact. Okay? Only rows with matching values in the unvariable will be retained. And the missing values will be filled if needed. Let's see some examples. So let's first do an outer join. Outer join is the most generous. You see it will not lose any information. This is the left table. A right table are employee and sales. So 3, 4, 5, 6. They are also there. Right? So it's the most generous one. If you don't want to lose any information, use an outer join. And if we use a left join, by the way, the argument is called how. If we do a left join, you see the left table is complete, but the right table is not. Employee 5 and 6 are removed because they don't have matching employee IDs. And right join will keep the right table complete. 3, 4, 5, 6 are kept in the result, but 1 and 2 are gone because the left table has 1 and 2. Don't care the left table. And lastly, sometimes when we join two tables, the two tables have different names for the matching variable. For example, let's manually change the column name of the employee ID from the original name to ID itself and call it df sales2. Okay, so now in df sales2, the employee ID is just called ID, but in the first data frame, it's still called employee ID. So now they have different names. So it's not a big problem because you have the option to specify the left on variable and right on variable. In the left table is in the DF employees table, the ID is called employee ID. So left on equals this. And in the DF sales 2 table, the ID is just called ID. It doesn't matter, right? And then let's do a left join. We get this result. And notice that there are two ID columns. It will not automatically remove the redundant column. If you want to drop it, you can just add a drop method at the end. Okay, then no repetition will be good. All right, right. All right, we are done with the first two sessions in data management, which is great, very neat. And tomorrow we will start to talk about how to handle numeric data. We will zoom in the issues we need to take care for numeric data. In particular, how to pre-process numeric variables and how to deal with missing values in numeric variables. All right. If you have any questions, you can stay. Otherwise, free to go. See you guys tomorrow. Bye.